I'm Zaza Kandelaki, a programmer and an inventor. Today I'd like to present one interesting invention that seems to me very promising, as it can turn into a real game changer as a basis for highly efficient, environmentally safe and noiseless, quiet passenger transport. Well, nearly every one of us has heard or seen the effect of magnetic levitation, and the most interesting thing based on it, the maglev trains. I am not an inventor of the magnetic levitation itself. That was known long before my invention. If you are familiar with this effect and devices based on it in more detail, you probably know that magnetic pillar trains consume a huge amount of energy. And even no matter what way is used for the levitation, repulsion like in the Japanese maglev, or attraction like in German trains, it's pretty easy to understand. Lifting any large mass, such as a train, requires a lot of energy, and physics does not allow us to extract energy from nothing, so we are forced to spend this energy. So, what is the peculiarity of my invention? For stable levitation, my magnetic frame, I call it platform, requires absolute minimum of the external energy. How? It consumes thousands of times less energy than any electromagnetic coil that keeps the whole mass in the air, either by attraction or repulsion, because the external energy for the levitation of my platform is required only to maintain equilibrium and not for its rise and retention. The main job of keeping the whole mass in the air is provided solely by the force of permanent magnets, arranged in such a way that a completely stable effect of levitation is provided. The platform demonstrates absolute stability in all directions except one. It's well described and confirmed in the Earnshaw's theorem, and only this one direction is stabilized by the electronic controller. The more precisely we adjust it to keep it in the very center, the less energy it takes to maintain it in this position. The video shows that to maintain the platform in the center, the current is only 30 milliamps at a voltage of 12 volts, and this is also not the limit. Using such a method of levitation, say for a train, it would consume even less energy than to illuminate the salon of the same train. Thank you for reviewing. This is the magnetic levitation, which is very effective, and it takes only about 70 milliamps of current. It's very stable. You can see the gaps between the coils and magnets. 30 milliamps total current. It's quite stable.